I do this, the example that we did yesterday, the only example that we did yesterday, I tried to show you like every step of the way, but very quickly you see that if you just factor the bottom and you set that equal to the two separate fractions, that it always is going to work out the same way. So look, this one's way easier to factor, right? No coefficient in front. So I always just factor it underneath here. 3 times 2 gives me 6, plus 3 minus 2. Oh, I'm sorry. Maybe I marked it out. Let's do this one then. Sorry, go to this one. Now we have to do uglier factoring. Barf. I'm just going to factor this. I'm not going to factor by grouping because I'm trusting you can factor by grouping on your own, that you can multiply. But I'm just going to tell you what this factors into underneath this. And it factors into 3x times x. And I'm adding to get negative 5. So 2 times 1, 3 and 2 minus and minus. Yes, that works. That's how I was taught to factor, just like that. That's amazing, right? No factor by grouping needed. So what we're going to do is we're going to break this up, right? So I don't know if you want to write the whole thing out every time, but we could say 1 minus 3x times 3x minus 2 times x minus 1 is going to equal something over one of those factors plus something else over the other one of those factors. So we call this decomposition of fractions because we're breaking them apart. We're decomposing them, undoing that common denominator, basically. I very quickly don't even show this step because, you know, I don't know, these take a lot of paper, and I tend to know what's going to happen. Every time, if I multiply this equation by that common denominator, right, this side is all going to cancel out, so I'm just going to be left with 1 minus 3x. And over here, the denominator will cancel out, and I'll just be left with what's left. Yes, dear?
So it doesn't matter which one, right?
It doesn't matter. It matters at the end which one you put back on top. But if you write a over x minus 1 and b over 3x minus 2, your answer is just going to be switched from mine, but it's going to be the same answer. It's just going to be in a different order. Does that make sense? So it just matters that at the end you go back and pay attention to which one you started out on top. So let's see. That's going to cancel out, and I'm going to be left with a times x minus 1 plus b times 3x minus 2. Every time that's going to happen in fraction decomposition. And then from there, you have to figure out what a and b can be. So there's a lot of variables in this right now. So we discovered if you just look at what makes each one of these go to 0, then you can solve for the missing a and the missing b. So it's kind of like you're solving two equations. So if I wanted this to go to 0, all I have to do is plug in 1 for x. So I say, let's make x equal 1. And I just do this problem. 1 minus 3 would be negative 2. This is going to go to 0, and I'm just going to be left with b. Is that true? That's easy. Do I need to show more work than that? Like, I'm just plugging in 1 for x. If I plug in 1 for x, I'm left with that. Usually one of them's pretty easy math. Everyone's fractions, usually, if there's a number in front of your x squared. So on this one, what do I have to do to make b go away? I would have to plug in 2/3. So over here, I'm just going to say, let's make x equal 2/3, right? I tend to kind of do this all together. And I'll show more work on this one. So I'll have 1 minus 3 times 2/3 equals a times 2/3 minus 1. And notice, I know that's going to go to 0, so I don't even waste my time writing it out because I know what's going to happen. 1 minus 2 is negative 1. 2/3 minus 1 is negative 1/3. Really stinks when you do all of it right, except for you subtract wrong, right? Happens to the best of us. But I could divide by, just kidding, multiply by negative 3. So does a equal 3? Do you agree with that? So what have we done? We took this thing that we can't integrate right now, and we've broken it up, and we can rewrite it into two separate fractions. And I can write it as 3 over 3x minus 2 dx plus, or minus, negative 2 over x minus 1 dx. And I just break it up into two separate integrals because sometimes you might need some u substitution. So don't think about it as one thing together. Think about it as two separate things. I don't know why I wrote that. So here's the great part of this problem. We haven't even done the calculus yet, right? All of this was just the algebra to get to a problem that now I can integrate. And almost every time, not always, these are going to end up some sort of ln's. If you need a u substitution, then do a u substitution. On this one, off to the side here, you can start out. If you made u 3x minus 2, what would du be? 3 dx. Oh my gosh, does it work out perfectly? Do you need to rewrite it with u? It's up to you. I see that it fits perfectly, and I know that that's just going to be 1 over u. If it helps you to write that out, write 1 over u. If you know automatically it's just going to be ln of the bottom, I'm okay with that too, right? Like, it's up to you at what work you need to make you feel comfortable with this. So I'm going to say I know that that's just ln of 3x minus 2. Is it okay on this one? I could separate that minus 2 out. Right? That's the same as this because the negative 2 is just like the coefficient. And then again, is that going to fit ln? Because on this one, if you made u equal x minus 1, then du would just equal 1 dx. Right? It fits perfectly. So it would just be minus 2 ln of x minus 1 plus c. Notice I'm putting my absolute value bars around it. And then the even better part is when you have a bunch of ln's, you can simplify them using properties of ln's, remembering that you can put numbers in front, right? They can go in as exponents. When you multiply, when you add ln's, you can put them back together as multiplication. When you subtract ln's, you can divide, which means on this one, I believe I could write that as 3x minus 2 divided by, because that's a minus, and I could stick that 2 up here as x minus 1 squared. Notice I dropped my absolute value bars on the bottom because if you square something, it can't be negative, plus c. And if you tried your homework last night and you looked at the back of the book, they tended to all have ln's together, right? They never left two separate ln's because you can always put them together. Is fraction decomposition a huge component of the AP exam? No. So I don't want to spend 7 days on this, but it's a useful thing. If you're going to take calculus in college, you're going to need to know it. And it's kind of a nice thing, a way to integrate some stuff. But that's the idea behind it. And then they throw tricks at you, like you might need to long divide first, because this only works, partial fraction decomposition only works if the degree of the numerator is less than the degree of the denominator. So if the degree of the numerator is bigger than the degree of the denominator, you can't break it up yet because you end up with something on the top that, like, it doesn't work. And so there's a great example on page 363, example 2 of one of those, and I'll do the long division on this, but I really don't want to do the whole thing. But this is also an example of a problem that you can't just break up because the degree of the numerator is bigger than the degree of the denominator. So what you have to do is long divide so that you get something plus what's left over, and then you can still do partial fraction decomposition and all the other fun stuff that was in the last problem, plus long division, right? It doesn't get better than that, kids. Do you ever think in life I could give you one problem that, like, tested all of your math you ever learned? I think that's about it, man. Best part about long division, you got to fill the zeros in, right? So if I'm dividing this on the bottom, that would be like x squared. Is this the exact problem from the homework? Is this your homework? It's from the example? Okay, that's it. Plus 0x minus 1. And then on the inside, I would have 3x to the fourth plus 0x to the third plus 0x squared plus 0x plus 1. Woohoo! You might say, why can't I do synthetic division? And that's because the bottom is not linear, right? Like, you can only do synthetic division if it's like x minus a on the bottom. You can't do it when it's something higher than x to the first power. The great thing is there's a lot of zeros here. It's just keeping everything lined up. So to get this, wouldn't this be 3x squared? Yes? So I could take this and multiply it by all of this, which means it's going to fill in 3 of these. And I'm going to get 3x to the 4th plus 0x to the 3rd minus 3x squared. And when we do division, what do we do now? We subtract. So I like to subtract everything to keep my sign straight. So I go through and say minus, minus, and if I minus a negative, I make that a plus. So I distribute that minus sign all the way through because it just helps me keep things straight. It's up to you on how you want to do it. But that makes this 0, this is 0, and that would leave me 3x squared. Bring down the next number. Actually, I could bring down the next 2 numbers because I have 3 things, but and then what would that be? 3? And then I would get 3x squared plus 0x minus 3. And then again, I'm subtracting. So I get a remainder of 4 here. Do you remember what we do with our remainders? So then we put it over what we were dividing by, which means what have we done? Made a disaster. We've made something we can integrate now. So now we would integrate 3x squared plus 3 plus 4 over x squared minus 1. Can you integrate 3x squared? Hopefully. Can you integrate 3? There's high hopes here that you don't need to do partial fraction decomposition here because you think, oh, it'll work, right? If I pick this as my u, if u is x squared minus 1, what's my du? 2x. Is there a 2x up there? Is there a way I can put an x up there? Does this fit arctangent? Ah, so close. If it was only a plus, it would fit arctangent. It fits nothing, which means now you can integrate this part, but now over here separately, you need to do 4 over x squared minus 1 equals a over x plus 1 plus b over x minus 1 and do all that fun work in addition to all the other work we've already done. What's wrong, Colin? You have no clue what I said?
Yeah, that whole like
You can integrate this. Yes, you don't need any special tools. You could just say the integral of this is 3x cubed over 3 plus 3x. Yes? Just the good old-fashioned power rule. But we can't integrate this. So this is what we learned yesterday. You have to factor the bottom into x minus 1 and x plus 1. And I just set up that fraction decomposition where I could go through and multiply this, and I would get 4 equals a times x minus 1 plus b times x plus 1 if I did all the canceling out. And you have to set it up and do it like we did yesterday. So the tricky part about problems like this, I think, is 1, they're just a whole lot of work. But 2, it's easy to forget about that part at the beginning. Like I've done ones before where I did all the work, I did this part, I solved it, got my LNs, checked the back of the book, and I forgot this part in the front. That's in addition to your answer. Number 7 is like that. Like number 7, there's like something out front, and then there's the LNs, because number 7 is a long division problem. It doesn't. Well, we'll get the same answers. If you do the other way, I promise it's the same. Your negatives might be different than mine, but in the end, it works out the same. Did we do some of our homework last night? We should take an anonymous poll to begin with. Like, how many people, no judgment here, I won't yell at anyone, how many people did, like, more than 3 problems last night? How many problems did I give you? Like 7? it be wouldn't it work out that way? Like if we plug, alright, I'll just do this instead of doing those. If I plug 1 in there,
You still get the same. It's just like they have A as 2.
I would get 2b equals 2, and if I plug negative 1 in there, I get negative 2a equals negative 2, so I would have negative 2 over x plus 1 plus 2 over x minus 1, so I'd have negative 2 ln of x plus 1 plus 2 ln of x minus 1, right? And so I would switch it around if I was doing this, because I would want to say, ooh, I could do division here. So you could write that as 2 ln of x minus 1 minus 2 ln of x plus 1. So I would write that as ln of x minus 1 squared divided by x plus 1 squared. Is that the answer they have?
For the they have 2 ln of the absolute value of x minus 1 over x.
Well, it's the same thing, right? They have their 2 on the outside. So if they have the 2 out here, but they have the x minus 1 on top. That's what matters. And it works out the same way that the x minus 1 will be on top, because the negative would be the one on the bottom. So the book left their answer like this. I put my 2 inside, but it's the same thing. Well, no, all the rest is there too. So then you'd have x cubed plus 3x plus all that, plus c. And the one in your example 2 in your book is this example that they go through it, so maybe a little better work than me. Now try example 7, or exercise 7, which is the one I gave you. Alright. Really had high hopes that we were gonna double up here today, kids. Let's just see what we can do. It's really not that bad. Some people did all this already. It is biology. Tonight's homework is only 4 questions, and we get through this.
To be honest, I did this morning.
So this is really one formula and learning what the stuff means. So just really quick, I know you've talked about this before, especially in biology, that logistic growth, we can talk about population growth, right? We can talk about that the rate of a population, right, has a maximum point of where it's growing the fastest, right? And it can't get close to 0. And then up here, remember what that's called? Like when your population gets so big and it can't get any bigger. The carrying capacity, that's your other asymptote if we're talking math-wise. But this really does also fit an exponential growth model in terms of the population, the rate that it's growing. So, if you look on the next page here, we can say that the growth rate approaches 0 as the population approaches a maximal carrying capacity m, then we get this lovely equation. So what does all this mean? M is the maximal carrying capacity. Do I need to write all this out? Figure all this out. P is your population. K is your growth rate. T is your time. So really, there's a couple questions I gave you on your homework today that if you know what this stuff means, then these problems are super easy compared to the problems that you had to do for yesterday, or maybe that you have to do tonight. They're going to give you an equation with this stuff filled in, right? It says the growth of a population P, where T is measured in years, is given by this derivative, basically. dP over dt equals 0.008 P times 700 minus P. Find the carrying capacity of the population. In the formula on the previous page, what did I say the carrying capacity was? M, which in this case is 700. Find when it is growing the fastest. Oh, what did I write on this other page? Oh no, did I say when it's growing the fastest? Growth is maximized when the population reaches half of its carrying capacity. So if we know the carrying capacity is 700, and we know it's maximized when it reaches half of its carrying capacity, 350. I'm okay with just 350. I mean, if this was an AP test, we would probably need to say more, right? But if it just said, if it was an AP test, they would not have the word it in there. So what about part C? Find the rate at which the population is growing when it's growing the fastest. What does this word rate tell you in terms of calculus talk? Derivative. Find the derivative of the population at which the population is growing when it's growing its fastest. Is this already written in form of a derivative? Which means they just want you to tell me the value of this when it's growing its fastest. So if we know it's growing its fastest at 350, is that just telling me to plug 350 in here? You see what I'm saying there? Rate means derivative. So all I'm going to do in here is I'm going to write this up here, but I'm just going to say 0.0008 times 350 times 700 minus 350 is 350. And what'd you get, Philip?
98.
The rate that it's growing its fastest. I don't know. It's weird to talk about people in terms of population growth. But if we were talking about rabbits here, we could say that the rate that it's growing, like when it's growing its fastest, it's increasing like 98 rabbits per year. Does that make sense? It should be like 98 per year. I mean, people per year. That sounds weird to talk about people growing, but that's not so bad, right? It is all it is. And so I just gave you four problems. If you did not do yesterday's homework, you need to do yesterday's homework as well. 1 through 13 odd. Finish it. And then these four problems, I promise, are just about carrying capacity and knowing that what to do on that. Like just like I just did. I promise.